To begin our discussion of ancient instincts, in this video I'm going to give you 3 examples of how the state and the public often reject economists' proposals in the water and sanitation sector. I want to make 2 points. The first is that the rejection of economists' water policy proposals is widespread. It happens all over the world, in both rich and poor countries. And it happens for various kinds of water policy problems. The second is that the rejection by the state or the public is often strong and passionate. I'm not going to focus on the distinction between the actions of the state and its citizens. These can, of course, be different, but often they're not. Both citizens and government officials often appear to act upon ancient instincts. My first example involves the elimination of open defecation in South Asia. The lack of proper hygienic disposal of human feces is a huge public health problem. The problem is most severe in places where people defecate in the open. I won't tell you how many children are dying because of open defecation because no one knows, but it's certainly a big number. There are on the order of 1 billion people in the world who defecate in the open without any toilet facilities. Many of these open defecators are in South Asia and the rural areas of sub-Saharan Africa. Water and sanitation sector proposals have been trying to find a solution to this problem of open defecation for several decades now. What have economists had to say about this problem? For many years, their policy advice was to subsidize latrines because of the negative health externalities. But this advice largely didn't work. In fact, recent research suggests that people actually like to defecate in the open. Reporting on their survey results, the authors of this paper say many survey respondents' behavior reveals a preference for open defecation. Over 40% of households with a working latrine have at least one member who defecates in the open. A policy breakthrough in terms of how to eliminate open defecation came out of community grassroots work in Bangladesh. The approach is called Community-Led Total Sanitation, or CLTS. The breakthrough actually came from explicitly ignoring the advice of the World Bank and donor economists and refusing to subsidize latrines. In fact, today many economists argue that improved water supply services such as point-of-use water treatment should be subsidized, but latrines should not. This is just the opposite of their advice only 10 years ago. So why is it difficult for economists and wash sector professionals to understand human behavior about sanitation and design sound policies to improve public health? We'll talk more about CLTS in this course in future lectures. A second example concerns efforts to privatize water and sanitation services in both industrialized and developing countries. In France, private sector involvement in the water supply sector has been accepted for decades. 35 years ago, Margaret Thatcher's government in the UK launched an even more ambitious privatization effort than the French privatization model. Many economists saw the UK privatization effort of complete divestiture of public assets as the vanguard of global reform. But it has not worked out that way. In both industrialized and developing countries, there was and is a great need to improve efficiency in utility operations and production, and to improve efficiency in the consumption of water, so water is not wasted. Starting in the 1990s, economists began to push the idea of private sector operators bringing a business orientation to the municipal water and sanitation utilities in developing countries. The push to privatization was not limited to water and sanitation. The World Bank and other bilateral donors pushed hundreds of privatization deals to involve the private sector in public enterprises of all kinds, including telecommunications and, to a lesser extent, in water supply and sanitation. Based on the empirical evidence, many of the privatization deals in all sectors seem to have been at least partially successful. Private sector involvement in telecommunications is now widely accepted. But in the water supply sector, there's been a strong pushback, even in France. This paper in the journal Water Policy was published in 2012, and it describes the politics involved in the return of the drinking water supply in Paris to the public sector, out of the hands of the private operator. And the debates in France have been passionate. Again, we'll come back to this topic of privatization in a future lecture and examine it in more detail. Let me give you a third example of the state rejecting economists' water policy proposals. This one relates to the design of municipal water tariffs. Utility managers who work in megacities of the developing world are struggling to address the challenges of population growth, urban agglomeration, globalization of supply chains, and climate change. But they're working with a 19th century technological vision of a municipal water and wastewater network system. And these networks are very capital intensive and expensive. Almost all utilities in developing countries charge prices far below the real costs of water and sanitation services, and they have no cash reserves to improve and expand services or to fund climate change adaptation. Despite the fact that most water utilities in developing countries are effectively bankrupt, water tariff designs rarely follow economist pricing recommendations. From 2009 to 2012, I had the privilege to work with the Egyptian Water Regulatory Agency in Cairo as it attempted to design improved tariffs for Egyptian water utilities. So I had the opportunity to observe firsthand the political economy of water tariff reform. In Egypt, as in most low and middle income countries in the global south, water utilities use what is called an increasing block tariff, or IBT, to calculate customers' monthly water bills. IBTs are also called tiered pricing. The basic idea is that households are charged a low price for the first several cubic meters of water they use. If they use more water than is sold in the first block at this low price, then water in the next block is charged at a higher price. And if water use is more than the volume specified in the first and second blocks, then the water in excess of this combined volume of the first and second block is charged at an even higher price. This slide shows 3 examples of IBTs from the Asian Development Bank's Water Utility Data Handbook. These are for Seoul, Hong Kong, and Osaka. You can see that the sizes of the different blocks are different in different cities, as are the volumetric prices in each block. This next slide summarizes data from a survey conducted by Global Water Intelligence. It shows that most water utilities in developing countries are now using IBTs. The second most popular tariff is the Uniform Volumetric Tariff, but its popularity is declining. In the past, uniform volumetric tariffs were widely used in China, but in 2014, China announced that all cities in China would need to adopt IBTs in 2015. This policy change will affect a major portion of mankind. The basic rationale for the use of IBTs is that they help poor households. Because poor households are assumed to use less water than rich households presumably will pay more per cubic meter of water than poor households if an IBT is used to calculate household water bills. Rich households can thus cross-subsidize poor households. The IBT seems fair and make intuitive sense, right? Or is this intuition supported by an ancient instinct? Poor households use less water than rich households, right? This figure shows a scatter plot of data on household income on the horizontal axis in US dollars per month versus monthly water use on the vertical axis in cubic meters per month. As you can see, the relationship between water use and income is all over the place. There are rich households that use little water and poor households that use a lot. This table shows the correlation between household income and water use in cities for 4 developing countries: El Salvador, Kenya, Sri Lanka, and Senegal. The relationship between household income and water use is positive but very low. One of the reasons for this low correlation is that household water use depends a lot on household size, and household size is not highly correlated with household income. So, a rich family may have few members and use less water than a poor household with many members. Because almost all utilities in developing countries charge prices that are below the cost of service, all households are subsidized. Do IBTs ensure that poor households receive most of these subsidies? What are the implications for the distribution of subsidies across households with different incomes? This figure shows the proportion of total subsidies received by different income quintiles, that is, groups that contain 20% of a population, for 6 different water tariffs for a representative city in a low-income country. The tariff structure on the left is a uniform volumetric tariff. That is, a tariff where everyone is charged the same price per cubic meter. The second through 6 tariff structures on the right are different variations of IBT structures. In this case, the IBTs have 2 blocks. The size of the lifeline block is 10 cubic meters. For purposes of comparison, the volumetric rate in the second block is set to generate the same revenue as the uniform volumetric tariff. The vertical axis shows the proportion of the total subsidies received by households in each income quintile. The results are the exact opposite of what you want. The richest quintile receives the highest proportion of the total subsidies, and the poorest households receive the least. There's not much difference across tariff structures. Basically, all the tariff structures do an equally terrible job of targeting subsidies to the poor. These results suggest that the IBT structure is not doing a good job of targeting subsidies to poor households. In fact, poor households in the lowest income quintile are getting less than 20% of the total subsidies. Households in the highest income quintile are receiving a higher share of the total subsidies than any other income groups. This is partly because all the water sold is subsidized, and the more water you use, the more subsidies you get. Again, we will come back to water pricing and tariff design in more detail in a future lecture in this course. But these results present us with a puzzle. If IBTs are doing such a poor job at their intended purpose, why are they so popular? In each of these three examples, there appears to be something puzzling going on. Open defecation is a huge public health problem, but it is surprisingly difficult to change the preferences of many people who like to defecate in the open. Many attempts to involve private sector in the delivery of municipal water and sanitation services have been at least partially successful, but they are often wildly unpopular, even in Paris. And IBTs are not delivering subsidies to poor households, but they're still perceived as fair and are popular throughout both the Global South and the United States and Europe. How can the majority of tariffs in low and middle income countries be working so poorly? And how can the World Bank, OECD, and the United Nations all be recommending that utilities in poor countries use these tariffs? Is the perception of fairness more important than actual performance? What's going on here? There's something strange about water. What is it? My argument is that in order to get better at using economic policy instruments in the water sector in developing countries, we have to figure this out. In the remainder of the videos for this week, we will start to unravel this puzzle.